For this year's dinner event, our guests were able to truly experience the science behind curry and rice, a Sri Lankan banquet prepared by Dr. Mahinda Abuwardena and his team complemented 3 scientific presentations. In addition to preparing the meals, Dr. Abuwardena, a principal research scientist at CSIRO Food and Nutrition, also highlighted the nutraceutical effects of spices in his presentation, along with testing the audience's knowledge of curry ingredients with a curry quiz. Additional insights into the Sri Lankan culture were also very interesting. Dr. Tony Bird from CSIRO also provided insights into the health effects of rice and the factors that affect the glycemic impact of rice. Our final speaker was Ben Lewis from RIOZ, the Royal Institute of Australia, and he gave great insights into chilies, the heat scale, and the best ways to stop the burn. Here are some of the highlights from our presenting speakers.
What's this?
I'm just scared to say.
That's the mangosteen, queen of fruit or a spice. I call it, some others do have them because they are same family, 2 different species, if you like. This is a Garcinia. They are Garcinias cambogia. This is a souring agent, very strong souring agent called Malabar tamarind, and Sri Lankans call it Goraka. Exclusively used for preserving fish and that sort of thing. And it's the same, look at the same looking, all that, but this one is very sweet. This one is totally opposite, but this thing gives you hydroxycitric acid. It's good for the colonic as well as anti-obesity action. So there are, actually one of my friends in the US got a couple of patents on the Garcinia for prostate cancer. So there are, Garcinol is the active compound. Some of the medicinal properties of spices, they are, you name it, spices will do it, so to speak. So antifungal, antimicrobial, dental pain is a specific one for cloves and cardamom too, I think. Indigestion, antiseptics and so forth, antibacterial. Even there are anti-obesity and anti-cancer, as you know, curcumin, which is in the phase 3 clinical trials, it is of turmeric. So if you really look at it from the pharmacological point of view, the most pharmacological agents, prescribed medicine, about 25% has a plant origin. So anything from, it could be from antihypertensives to cholesterol lowering or whatnot, they are of a plant origin. They may not be the real thing in there, but it's a template drug to further synthesize and modify the actions. And higher plants, including spices, are contributed to those templates, or sometimes very close to it, very little refinement. And they are lead structures for synthetic modification and activity. And the spices came from the world species, apparently, used in early days to describe a group of exotic food supplies. And according to USDA, there are about 200 plants in this category on the USDA side. And they are included in not only for rice and curry or curries.
So let me just start by giving you a bit of an outline of what I hope to cover today. So first of all, the importance of rice as a crop, as a food, and in terms of its nutritional contribution to the diet, its nutritional attributes and health impacts, and in relation to that, the importance of certainly starch quality, the glycemic response. How do we measure that? And let's not lose sight of the non-glycemic component, that component of starch that we consume that doesn't raise blood sugar levels. Then I'll talk a little bit about some of the research we've been doing here on starch quality in conjunction with people elsewhere in Australia and also overseas. And then I'll finish off with perhaps a big picture view. So let me just sum up where we're at with white rice. So it's energy dense, it's nutrient poor, it's essentially mostly starch. There is some protein, and for a number of populations, rice is an important source of protein for them. but for all intents and purposes, the endosperm consists of starch, and that starch is a major contributor to postprandial rise in blood sugar. And most processed cereals have a high glycemic index, and generally rice is no different. The range of lower GI foods is expanding, so that the job of reducing the GI of your diet is getting easier, I think. The Dungara, for instance, and also basmati are low to medium GIs, as I said before. Low GI and high rice, high resistance starch varieties are being developed by us and others around the world. You also need to consider other cereal foods, low GI white breads, for instance, and a number of those are coming onto the market. There's barley flatbreads out there that have exceptionally low GIs in the range of about 40, 44. Sourdough breads have a lower GI than their counterpart or white equivalent. Other food constituents, meal components influence GI. Sushi, for instance. The white rice that's used to make sushi is very high in GI, but the combination of vinegar and also the seaweed, the alginates, pull down the GI quite substantially. Cooking and cooling rices will increase their resistant starch content and also lower their GI, and repeated cooking and cooling cycles increase the amount of resistant starch content, and that's what you find with conjugates.
The culinary world would be a lot poorer if it weren't for chilies. They really do add a whole different element to food. Amazing taste, but also that fiery sensation that at least some of us love. Talk amongst yourselves for a second. So what's happening now? There's a chemical called capsaicin, which Mahindra sort of mentioned. And it's binding to certain receptors in my mouth called TRPV1. However, some of these receptors are actually on nerve cells, which normally signal for temperature changes and temperature inside the mouth. So when these receptors are actually activated by the capsaicin, and it activates that nerve, the brain actually interprets that as a change in temperature, because the nerve is actually a temperature sensing nerve. So this is a little, a little intriguing. Your mouth isn't burning. There's no tissue damage going on, but your brain is convinced that there is. So what, as most people who have eaten chilies would know, water doesn't reduce this feeling, which it would if it was actually burning. The reason is the chemical structure of capsaicin has actually what's called a long carbon chain, so it has lots of atoms of carbon hanging off one end. This means that it doesn't dissolve in water, but it does dissolve in things like oils and fats, and other liquids which have a similar structure. This is one of the reasons that milk provides a relief from the heat. There's a protein in milk called casein, which actually binds to the capsaicin. Now what it doesn't actually neutralise the capsaicin in any way. It actually just picks up the capsaicin and washes it away out of your mouth and away from your tongue. So it's not actually stopping the capsaicin from working, it's just moving it on away from those TRPV1 receptors on your tongue. Here's something really, really cool that I found out though. Birds can't actually feel the heat from chilies. All right? That means they can eat chilies to their heart's content. What's more, after they've eaten the chili seeds in the bird's gastrointestinal tract actually start germinating, and then they're released in the bird's droppings. This actually means that birds are one of the biggest spreaders of chili seeds around. Compare that with mammals. The seeds in chili seeds in a mammal's digestive tract are broken down, and that's one of the thinking between about capsaicin. Why birds don't sense the heat and mammals do. Birds actually provide a purpose for the chili plant. Oh, well, actually, while we're talking about seeds, time for a little bit of myth busting. Contrary to popular belief, the seed isn't the hottest part of the chili. It's actually, if you cut open a chili, it's the white membrane, sort of pith part of it. That's where the chili is stored and produced. Some of it does soak into the into the seeds. But it is actually that pith. So if you're trying to reduce the heat, when you're removing the seeds, also try to remove as much of that white pith or that white membrane as you can if you don't like the heat.